In this problem, we have a bowling ball pendulum. Right here, it comes down, and this is the original position. And then they pull it back to position 2. And in this problem, they're wanting us to find the potential energy for original position, and position 2. And we're going to go to what they've given us in the problem, which is the mass is 5 kilograms for the bowling ball. Height 1 is 0.5 meters, which is right here, 0.5 meters. Height 2 is 0.7 meters. Then H is height overall, and the whole thing is 1.2 meters. And then they also give us kinetic energy, which equals 34.7 joules. So the first thing I go to find is going to be the original potential energy of the original bowling ball position. So I'm going to use the potential energy formula. So potential energy is mass times gravity times height. So I come down here, and we're going to do potential energy equals 5 kilograms times 9.8 meters per second squared times 0.5. Potential energy is 24.5 joules. And the reason it's joules is because kilograms and meters per second squared comes out to be joules. And we're going to do the same thing for the position 2. We're going to take the potential energy formula, and we're going to take the mass is 5 kilograms. The gravitational is 9.8 meters per second squared. And the height for this one, if we're going to use the whole height, is 1.2 meters. And that gives us a potential energy of 58.8 joules. So we have the two potential energies for both positions. So now we're going to go and try to figure out the velocity of the bowling ball. So we're actually going to use the velocity formula. Velocity equals square root of 2 times gravity times height. So we're going to come over here, and we have the original formula written down again. So then I take velocity equals square root of 2 times 9.8 meters per second squared times the whole height again, which is 1.2 meters. And once we put that in our calculator, we get a velocity equals 3.7 meters per second. So that is the velocity of the bowling ball.